a couple of weeks ago I introduced this little project that I'm going to be doing, and it's all going to be based around this diyBMS by Stuart Pittaway. And it seems to have generated a bit of interest, which is excellent news because I think this is a really good project. Stuart's certainly working hard on this when he's got the time available to him, so much so, within 48 hours of me releasing that last video, well, this PCB, well, we don't need that one anymore because he has replaced it with version 2.1, March 2018. So we'll get rid of the old one, and the improvements are that the silk screen there has been adjusted for that diode, I did mention that, and that track on the back has been beefed up to carry the current when it's in discharge mode. So those are both really excellent improvements. And due to the wonders of Chinese manufacturing, I've managed to get plenty of these here in the shed, so I've got enough for my 7S 20p pack. Now, I have been practicing on one of these cheap surface mount practice boards here, and I chose the 1206 resistors because that's the size that's on the diyBMS, and I started off alright actually, and well, I think it improved. And down here, by the time I got to the bottom, well, I was realising that you don't need much solder paste at all, and of course that is quite difficult with this syringe here, and of course the size of the hole on the end of it. So thank you to those who commented on previous videos and pointed out that yes, you can buy these blunt needles here, and I think this is a number 18. I might be wrong. I think the colour on the end indicates the gauge of the needle, but even that one, well, I found it quite difficult to get the solder out because this is quite a long thin needle, and that wasn't brilliant. But I was also recommended to get some of these cone types, which are just plastic, and this was much better. I did get a whole range of these in different sizes, but I found this pink one was about right for me and for the components that I was trying to solder. But even then, getting the right amount out of this large solder tube was proving very difficult, and I came across an idea when I was searching the web, and I decided to buy some of these, which are just normal. This is a 1ml 1cc syringe here, and these are meant to be one-use medical, but actually this is much better because although it only holds 1 milliliter of fluid, well, that gives you much more movement in the plunger there for a small amount of solder out of the end. Now, the problem is these aren't designed to be opened up, really, but they do pop out, and then we can just take some solder out of here, plunge it straight into there, and well, push it down, I guess, towards the end, and that seems to work quite well. I'll see if I can pop a bit more in there. Perhaps this solder paste needs to warm up a little bit more. Now, with less than half a milliliter of solder paste in this new 1ml syringe here, I think that's going to be more than enough to solder up one of these boards. Now, the only problem with these smaller syringes is they don't have the locking mechanism. They screw fit, but actually I found that they fit on quite nicely there, and that's plenty solid enough to actually dispense solder. And there you go, I'm getting some solder out of the end of the nozzle there. Excellent. That's a bit too much. Now, unfortunately, the idea of syringing on each of these pads, well, I think that's going to be quite time consuming, but Colin Hickey came to the rescue, not for the first time on this channel, and he found a service online which allowed you to put in the Gerber files from your PCB, and it would print out this, or it would generate the file so that you could print it out yourself. And this is a 3D printed solder stencil which absolutely matches the PCB here, and this has to be printed extremely thin. I did 2 layers at 0.1 millimeters per layer, and I had to break out the 0.2 millimeter printing nozzle to get the fine detail of particularly the REG 710 voltage regulator. And this just sits on the PCB and lines up perfectly, and then you squid some solder paste through all these holes, and hopefully then you peel it off in a nice fashion. So I'll get a bit of tape down this side just to hold that on, and yeah, we'll get soldering and pasting. So there we have the stencil stuck down. I'm just going to smear on probably far too much paste there. In fact, I've used yeah, that's probably far too much paste, but hopefully if I push that around a bit, it will go in all the right places. Now, probably not the right tool for the job, but I've got a decorator's palette knife here, and hopefully if I push that in without knocking the camera too much, apologies for that, then hopefully I'll get solder in all the right places. In fact, if I push against it, I'm saving some solder there, aren't I? So let's just push it all the way through. Yeah, perhaps not the best tool for this job, but it seems to be working. Well, I don't think that's done a bad job at all before I remove the stencil at least, but you'll notice that I haven't done the components at the top. I thought it would be interesting to do that in the old-fashioned way, and then when I go through and heat everything up and get all that solder to flow, we'll see if the joints look better on those at the top or these that I've used the stencil on. So yeah, I just now need to peel away the stencil, which will hopefully will come off reasonably cleanly. And yeah, do you know what? I don't think that's too bad at all. I think every single one's got a reasonable coating of solder. Whether it's the right amount or not, well, I guess that remains to be seen. So I've now splodged some solder paste up the top there as well, and it's now time for me to become a pick and place machine. So capacitor 1 is a 2.2 microfarad. There we go, that's that one. And so is capacitor 2, which is that way round, and it sits just there. Now these capacitors that I've got are slightly wider than the pads, and that becomes a problem down here because potentially I might bridge some connections, but hopefully it won't be too bad. Capacitors 3 here, 4 and 5 are all 0.1 microfarad, 100 nanofarads. So that's number 3, and number 4 is just there. And the last capacitor, capacitor 6, is the one that's a bit worryingly close to capacitor 1, and that's the charge pump capacitor for the REG 710. Moving on to the resistors, well, R1 is the big discharge resistor here, and I'm going to leave that out. Not only is it through hole, I haven't quite decided what value I'm going for there. And R2 is this one up here, but before I put that in, we need to have a look at something. In the original schematic that I drew, this is R2 over here, and it's the current limiting resistor for the diode, which shows that the discharge circuit is active. It's switched on by the MOSFET down here, as the discharge resistor is also switched on, and it's been mentioned here as a 510 ohm resistor. But Stuart has updated the official schematic, I guess, and R2 is this one down here next to that same diode and the power resistor, and he's mentioned here is actually 47R, 47 ohms. Well, I think that is a bit too low. Using Ohm's law, we know that current equals voltage divided by resistance. Now, the maximum voltage that the battery pack should ever get to is 4.2 volts. So if we divide that by 47 ohms, then we get a grand total of 89 milliamps. Yeah, that's definitely a miscalculation or a typo there on the schematic. So let's have a think. If it was 4.2 volts divided by the 510 ohms of the original drawings, well, yeah, that's only 8 milliamps. So I think that's far more reasonable. So I'm going to dig out a 510 ohm resistor for R2. So I'll just go through my sample book of 1206 resistors here, all claim to be 1%, and find the 510 ohm. There we go, perfect. So there we have the 510 ohm resistor for R2. R3 is a 68k resistor, and R4 is 10k, marked 1002. R5 makes up part of the voltage divider, so the AT Tiny can sense the voltage on the batteries, and that one's 47k, and so is R9, which, where is it? R9, up here. There you go. R6, another one of the voltage divider resistors. Sit in there, thank you. 47k, no, 470k, that one. R7 has popped out upside down, and here if you just drop it a couple of times, yes, there we go. It's now the right way up. 680k for R7. There we go, that's the other part of the voltage divider. R8, R10 and R12 are all the same value, 2.2k, marked 2201, I think, is that right? Yeah, 2201, and we'll get them the right way round. It's worth noting that actually there isn't an R11 on this board. We miss one at 10 and 12, but that's okay as long as all the holes are filled. Diode 1 is the protection diode up there. That's to protect from reverse polarity. Now, diode 2 is the discharge LED, and I've got it here now. It does have a little marking on it, but I can't remember which way around it goes. So, it's that way around. With my meter in diode mode, I've been able to test that. So, actually, it's the other way round, isn't it? Not sure whether you can quite see that. Diode 4 is the status LED to say that the code's running fine. Diode 3 doesn't exist, so we've missed a number there, but that's fine. Diode 4 is a green diode. The PTC, the thermal fuse, goes up there at the top, and I think I'm right in saying this is a 1.5 amp PTC. So we're nearly there now. The smallest component, well, they're about the same as the resistors, but the pads for it are absolutely tiny, is the MOSFET there. And I think I've managed to get that in the right place. The next component's the R710 3.3 volt buck boost regulator, and identifying pin 1 on there was really rather difficult. So I've drawn a an idiot's guide here, and it is marked as R10C, and from this angle I need to read that upside down. I've done the same for the AT-Tiny 85 and the Adam 1250 as well, because I just wanted to make sure I didn't do anything wrong. And I don't think pin 1 has been marked on this silkscreen for the R710 or the Adam chip either, but the AT-Tiny is marked, so I can just make out that says R10C that way up, the wrong way up, so that should sit in there like that. The AT-Tiny is a bit bigger and does have a clear pin 1 mark, and as I mentioned, it is on the silk screen, so that, as he messes it up, you would imagine should be a lot easier to locate in the right direction. And checking my idiot's guide once more for the Adam 1250 ARZ, yeah, that seems to be the right way around. Right, let's get some heat on here. So here we go, here goes nothing. I've warmed up this handle a little bit, it's been running for 30 seconds, and I'm just now going to heat up the whole of the board, try and bring up the temperature across the whole thing reasonably evenly. The paste down at the bottom seems a lot drier, probably because there's less of it, than the paste down at the top, where I manually squeeze some solder out of the syringe. But anyway, we'll see, we'll take a look at that afterwards. Right, let's start concentrating the heat a bit more into certain areas. And there we go, we're starting to melt a bit of solder now. That resistor's gone, so's the one next to it. The capacitor, one side is, the other side isn't. Come on, capacitor, there we go. Oh no, that capacitor's moved. Grr. What to do about that? Get my tweezers. See if I can just shift it. Oh, I should have stuck the board down. Oh no, it's all going terribly wrong. Let's get that capacitor. No, that is not playing ball at all. And it's moved the REG 710. Oh, this isn't going well. So clearly my soldering still needs some work. This capacitor's moved and the REG 710, and I haven't even managed to heat these up enough to solder actually, but I wanted to get this sorted first. I carried on and did the top, and it's not too bad, but clearly there's a bit of rework that needs doing down here. Let me turn on the normal soldering iron. So I was able to sort out the capacitor quite easily with the normal soldering iron, but I think I need to heat up both sides of this REG 710 more evenly, and I'm using gravity, lifting the board up with that chip ever so slightly, so that when that solder flows, well, hopefully the board will fall to the desk here, and there we go, just like that. So there we have, with that little bit of rework down here, I think everything looks okay. So we will, well, we'll find out, won't we? I'll put some power into this, and as long as I can get 3.3 volts out of that regulator today, I think I'll call that a win. So I've got my power connectors here, and that's absolutely fine, but this doesn't go that way up, it goes that way up, which means my positive and negative, my red and my black cables, are the wrong way round. I might have to swap those pins, but do you know what, for now I'm just going to remember it's the wrong way round. So I've got 4 volts here on my bench power supply, and going into the black cable, which is a little bit worrying, and I'm going to connect up the ground there. So that is now live, and theory has it I should get 3.3 volts across C2 here, which is on the output of the regulator. So let's just hold that there. 3.297 volts. That's excellent, and that's all I wanted to achieve today. I've soldered up the whole board and I've got 3.3 volts on the output of the regulator. That's excellent. So I've got the regulator section working, but actually none of this other circuitry is working whatsoever because I haven't put any code on the ATtiny, but I think that's probably best for another video. Hopefully you've enjoyed this video. If you have, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching. Oh, I was meant to look at the differences of the soldering here, wasn't I? So down at the bottom there's definitely less solder, but they do seem a little bit shinier perhaps than at the top where there's a bit more solder. And yeah, I think all the connections are obviously good enough to make this work, but I think probably the solder stencil does make life easier, and it is applying enough solder to make all these connections as well. So yeah, especially since I've got another 6 of these to make, I'll definitely be continuing with the solder stencil. So thanks again to Colin for taking the time to create it.